Welcome to a new session of the ERNI Frontend community. Today we are going to do this session at the same time with the VR community of ERNI. So for do these sessions, we have created an environment world in the Metaverse, and there is our collaborating Rodrigo. Rodrigo, can you hear me?
Hello, David. Yes, I can.
Uh, nice place. Okay. Can you show us the
Yeah,
environment, please?
yeah, for sure. Well, as you can see, here is the beautiful scenario of the ERNI community. Here, some people are already talking and playing and just enjoying a nice evening with us here at this scenario. So, if you follow me through here, here is also a hall that you can see here. This a link to the ERNI page. So feel free to visit the page to learn more about ERNI and the community and so. And at my right hand side, you can see just a compilation of pictures that is 1 year at ERNI, just basic events and things that ERNI hosts through the year. And if you continue following me, you will see here is our playground with some participants here just enjoying the evening. Here you have something like a dart but with balls because dart is way too extreme for that. Also one a party game here with a score. Here's also a dog that is just chilling here with the people. And here we also have Carles just playing with the cat. Let me just put you 1 second to give you the ability to talk because you don't have it.
Hello, how are
And
you?
hello, Carlos. How is it going?
Fine, I am petting this cat. It's very
Are you
fun. And
enjoying
also I
the?
play, yeah,
Yeah.
I play with little basket and well, it's amazing this place. So for me, the first time here and it's fun.
I'm glad to hear that. David really have a lot of time just spent here creating this environment for us and to for us to enjoy. So thank you, David, for this, and thank you, Ernie, for providing the time also to give us some toys here in the virtual world to enjoy. Right?
Okay, thank you very much, Rodrigo. Enjoy the session.
Thank you.
So let me cut off the voice there. Okay. And okay. So yes, let's start. Carlos Arasil is a senior frontend in ERNI and lead of the VR community of ERNI. Will show us how create an virtual world environment from scratch and step by step using Unity engine. So let's start. Uh, Let me see. Okay. Okay, Carlos. When you want, can start. Carlos?
Thanks a lot, David. Good afternoon. First of all, we will briefly introduce AR/VR technologies. Then, we will take a look with software and hardware elements they are composed by. And lastly, we will build a small VR example inside the Unity 3D engine. VR is a technology that seeks to immerse you in digital worlds. Instead, AR aims to make a link between the digital and the real to expand the possibilities of interaction between the two planes. Today, we will focus mainly on the VR experience, although we will mention AR in several cases. VR technology aims to provide immersive experiences, and these experiences are its basic unit of measure. Everything we do in VR, is aimed to provide to the user access to experiences that makes a digital environment as vivid and close to tangible as possible. For this reason, VR systems are not only composed of headsets and controllers. This purpose of providing immersive experiences makes the companies explore a wide range of devices that aims to make these experiences as real as possible. These devices allow the users to feel VR worlds in the most real and vivid way possible. There are various types of VR experiences, all of them with multiple uses, both recreational and professional, and for the improvement of mental, physical and emotional health. Many think that VR is just video games. Still, VR has utilities that go beyond the limit of video games. If they try to create an entertaining and/or artistic experience, VR has the possibility of influencing our lives and our modus vivendi in a very tangible and authentic way. The application of AR/VR technology to our life can change our society's economic, military and entertainment paradigm. Since AR/VR would allow a soldier to go to the war without being present by using robotics combined with AR. We also could explore Mars without leaving the control room, fix a breakdown in inaccessible places for the human being. It can also be used to help people with agoraphobia and diseases that affect the cognitive system and behavior by exposing them to the fears and traumas in a safe environment, guided by a specialist. But one of the utilities that are being promoted to expand its use is the VR workroom. This kind of AR/VR experience is being promoted by companies like Facebook and Microsoft, among many others, to encourage close working environment, free communication, and collaboration without people being physically present. Usually, we are going to find a headset with a couple of controllers. These controllers, in most cases, will simulate our hands within the virtual environment. They will also allow us to move around the environment using buttons or small pads, call menus or other quick access functions that each application implements. If the user wants to increase the level of immersion of the experiences, there are extra devices that different manufacturers have been devising and putting on the market. These range from olfactory meters to additional movement sensors in the body to walkers that allow us to work or run without physically moving from the place. Currently, we can distinguish between three main types of setup. The first case is the dependent headsets. Then we have the standalone and the hybrid or mixed ones that combines the previous ones in a single device. The dependent headsets incorporate all the optics of the viewfinder, but they need to connect to a device, so it sends them the image to show. This concept is similar to attaching a screen to a computer, which has been the most common use case in the existence of PC technology. Examples of dependent headsets will be PlayStation VR, Valve Index, HTC Vive, or Oculus Rift. Standalone headsets incorporate all of the headset's optics, in some cases audio, and, crucially, hardware to run and render the VR software. These VR sets can be found on smartphones using cardboards, or headsets that incorporate hardware similar to smartphones, such as Oculus Quest, which has its own GPU plus CPU, audio speakers, wireless internet access, and connection to multiple peripherals using the USB Type-C connection. In these cases, the built-in hardware is not as capable as the external one, VR headset plus PC, but they allow running lightweight software entirely autonomously, and it creates a user experience that is much more agile, affordable, and easy to implement in everyday life. Some examples will be the Oculus Quest, smartphones with cardboards, and the Nintendo Labo Kit VR. There is a third case that is a hybrid between both. It is basically standalone headsets that can also be connected to external equipment. Some examples will be the Oculus Quest family. If we want to enjoy maximum performance, we need a powerful external computer. To display a smooth VR experience, the user needs a lot of graphics power. Each eye must maintain an average rate of 45 frames per second, so the GPU must render at least 19 frames per second. A video game console or gaming computer typically displays rates between 13 to 16 frames per second. For more frames per second, we already need medium and high-end equipment, with the consequential increase of the price. To put a price today, if we want to have a quality experience in VR, next generation graphics card are needed, plus a laptop or desktop computer, whose value is around 1,200 euros, and this price can increase much more. That only counts the computer then. The VR headset range from 400 euros to several thousand euros if we are already entering a professional VR headsets. Getting a VR experience dedicated solely to leisure in somewhat more affordable signs, for example, Meta Oculus, formerly called Facebook, have affordable headsets aimed more at entertainment than development, whose price is around 400 euros, and Sony PlayStation Console Plus VR headset kits is around 600 euros. Another handicap of the VR technology is that it has a more direct influence of the person that other user experience, unlike traditional ones that try to interact through the screen away from the eyes, such as a television or a computer monitor. The VR headsets interface with our cognitive process, tricking our brain into perceiving a digital world as real, and this, depending on the anatomy and biology of the user, can create many discomforts, from dizziness and vomiting in the worst cases to slight headaches. Our brain and eyes do not operate at 90 frames per second. This is an average quantification to give a minimum healthy experience for the user. It has been established that the refresh rate that guarantees the minor fatigue for the user is 120 frames per second. However, there is very little information on how our brain processes and perceives movement. This makes it difficult to determine the possible adverse effect that VR may have on particular users. And it has to be said, not everyone has problems with motion. Due to this lack of information, VR companies prefer to be cautious when implementing these technologies. For this reason, it's being implemented gradually and slowly. However, as happened with the jump from 2D to 3D in the 90s, many people will just need to adapt to get exposed to this technology, and by its adaptation, the possible bad symptoms will disappear. Although VR technology existed since the 90s, the access for the big public was not possible until recent years. We live in an exciting time, in which we can only dream of what else this technology could bring us. VR will be used by the general public. But before this can happen, the technology will have to overcome the following obstacles: fatigue and adverse effects, the acquisition price of the technology, user experience problems, which after resolving these difficulties translates into devices that are very easy to use at an affordable price and with a more robust technology that avoids its adverse effects with a more ergonomic design. And now we are going to practical part of this presentation. We will build a small example of VR world and enter on it. For the demo that we will carry out next, we have chosen the engine Unity 3D. In summary, we have different engines on the market to make video games, audiovisual experience, movies, etc. The main software engines used for VR applications are Unity 3D and Unreal Engine. Both use different development philosophies, but the needs and characteristics of the project you are making will make you decide which engine best suits them. To carry out the demo that we will do next, we will need to install the Unity Hub. Unity Hub is the start and control center where we can create, open and delete projects, install new versions of Unity 3D and manage our accounts. Using Unity Hub, we will install the latest available version of Unity 3D. We need a properly configured headset with our computer to test this demo that we will create. As an alternative, we can deploy the APK to a compatible headset like Oculus Quest.
Now we will create the project, so we click on New Project. Then different templates will appear. Then select the VR template as it includes some necessary plugins and allows you to make some specific configurations for your VR project. Now give a name to the project and click on Create Project. Now wait a few seconds for the project to be generated. Depending on the equipment, it may take a couple of minutes. Now, inside the new project, configure the project as said on the pop-up that appears. To do this, we will go to Edit, Project Settings, and select XR Plugin Management. Since I have an Oculus Quest 2 in my setup, I will select the Oculus plugin in all of the available deploys. In the case of using other headsets, another plugin will have to be used. We are going to use the Oculus Quest 2 hybrid headsets. We will change the project deployment to Android since, internally, Oculus Quest headsets have an Android operating system. This will allow us to deploy the headsets without using the computer if we wanted to. To do this, we select File, Build Settings, Android, and click on Switch Platform. This may take a while. Now, Unity will re-import new scripts and assets prepared for that build. Once the import is finished, click on Player Settings and within Player, we verify that the Android minimum APA level is 23, which corresponds to Android 6 Marshmallow. This ensures us wide compatibility with older devices. Okay, now we need to install a package that will make our life much easier. It's called XR Interaction Toolkit. To do this, we will go to Window, Package Manager, select the package from the Unity registry, and search by the package name. We select Install and wait for it to finish. We will use this Unity package because it already provides us with all the configurations and developments that we should do manually to connect the Unity input system with the different input devices of each headset model. So once we learn how it works, we can use it for all the other systems. Now, it asks us to activate the modern input system. To use it with this package, and for this, we will have to reload the project. Finally, we look for the package in the Package Manager again, to verify that it is installed correctly. We will take the opportunity to now install the samples that it gave us to use in our demo. We will select Import in Starter Assets. We will navigate in the project folders that have been created new with the starter assets to verify that they are there. We will add each starter asset, so that is visible in the project. We will open each of them and select Add. Then we will go to Edit, Project Settings, and Preset Manager to make sure that they have been added correctly and that we have the filters correctly set. We will add the right and left filters in our action-based controller script. To not waste much time creating an entire scene, you can use the Unity Asset Store. Many developers add assets that can help prototype or develop the ideas we have. In this case, we will look for a scene already created by a developer to add to our project. We search for Polygon Starter Pack and add it to Unity. The package manager will open, and we download and import the package to the project. We close the package manager and we will open the scene that will now appear inside the folders of the package that we have downloaded. And boom, we have a whole scene set up. As you can see, there is a bit of everything. It's a bit crazy, but this setup will perfectly serve to test if we can navigate inside it using VR. Now we will add the start point, to where the user will start, within this stage. For this, we will add an XR origin. Within the hierarchy of the scene, we will click the right mouse button and select XR. Then XR origin action base, and new game object will be created within the scene. That will be the starting point. We can move the game object to wherever we want within the scene if necessary. Then we will see that the children of the new XR origin have the controller scripts mapped correctly to the sample scripts we are using. Finally, we must add a script component to our XR origin so that it can receive the inputs. We select our game object and add the input action manager component. Then we add a new action asset. And select the XRI default input that the previously downloaded examples also provide us. If we want to move within the scene, we must add the locomotion system component. Within the hierarchy of the scene, we click the right mouse button and select XR, locomotion system action base, and a new game object will be created within the scene. Then we are going to customize how the user's movement will be. We want it to be continuous, both when moving forward and turning. To do this, we will first deactivate the snap turn provider script and add the continuous move provider and continuous turn provider components of the action base type. At this point, we are going to test if everything works correctly. We will need to have our headsets plugged in and configured. If all of this is okay, we should click on the play button within Unity. We will put the headsets on our head and we should see the program's executions already in the headsets. From that moment, everything I see and do in VR can be seen simultaneously at Unity's game screen. Whoa, this works! These two red rays represent my two controllers for each hand. Whoa, it seems that everything is there. It's very different from seeing it on the screen than here. Let's move! These coins like they can touch each other. The immersion is total. It looks like a children's amusement park made of plastic. Okay, let's play a little more. Let's see how we could improvise a flag with the ERNI logo inside our scene. I'm going to see if I find any assets with flags in the asset store. We search by flag and that they are free. This looks like it could work. Let's install it inside the project to see. Let's import the assets and we seek to see what they give us. It seems that there is some prefab that can help us. A prefab is a set of game objects and components packed and assembled, ready to be used. We add the flag somewhere in the scene. Let's see what material that flag uses. Now, what we will do is to add our texture with the ERNI logo to replace the flag material. And boom! We have a flag with the ERNI logo. It's not perfect, but it works. Let's see if we can put it in a better place. Looks like it's fine here. I think that's it. Let's try. Let's see where we have our little flag. Whoa, it moves and everything. Well, here we have the ERNI flag within the VR space. VR technology is still an experimental phase. Many companies still think that practical use could be given to it. VR is game-changing technology that will change the world as we see it today. So, I invite you to prove this technology. I assure you that after trying it, you will discover this new and exciting paradigm and realize the infinite possibilities it could offer to us. I hope you like this experience. If so, I hope you will join our AR/VR community. We will share what we learn with everyone who wants. So, we're waiting for you. I give the floor again to David. Hi David!
Hi, thank you very much, Carlos. So that's it. We will arrive at the finish of the session. So that's it. Thank you very much for attending this session, and we have the new session in 12 May or May 12th. Yeah, to May 12th. So yes, thank you very much, and until then, take care and bye.